Welcome back to the deep dive. Today we really need to talk about the absolute state of writing code in 2026 because if you are a developer right now or even, just working adjacent to dev teams,
Yeah.
you are living in a pressure cooker.
That is putting it mildly. It is a very strange time to be building software.
Seriously. On one side, you've got the business side just screaming at you to ship faster, use the new AI tools, move fast and break things.
Right.
Speed is the only metric that seems to matter. But on the other side, the threat landscape has gone completely off the rails. You can't actually afford to break anything.
Especially not security, and that is the classic tension, isn't it? Velocity versus security. For the last decade, security tools, specifically SAST tools, have been seen as the enemy of speed.
They're the speed bumps,
Yeah.
the blockers.
The Department of No.
Exactly.
Exactly. But today we're looking at something that claims to actually solve that paradox. We are diving into a new open source tool called MEDUSA.
MEDUSA.
Specifically version 2025.9.0, which just dropped in late January.
And this isn't just some patch update, right? The coverage coming out of Pantheon Security, who developed this, and the articles we've been reading are painting this as a bit of a revolution. They're calling it an AI-first security tool.
Which is a buzzword we usually, roll our eyes at.
We absolutely do. AI first is usually just marketing fluff for we added a chatbot.
Yeah.
But the mission for this deep dive is to see if MEDUSA actually earns that label.
Right.
We're going to find out if it can solve the three things that make developers hate security tools. False positives that waste your time, scans that take forever, and this new terrifying category of vulnerabilities that come from using AI agents.
And just to set the stage on the scale of this thing, the stats they're putting up front are, well, they're bold. We are talking about 74 specialized scanners, support for over 42 different coding languages.
42.
And this is the specific number that grabbed me, over 180 security rules designed strictly for AI agents.
Wait, 180 rules just for the AI components?
Just for the AI.
That is wild. But before we get to the AI stuff, I want to talk about the speed claims.
Yeah.
Because if a tool is slow, I don't care how smart it is, I'm not running it.
Nobody is.
They are claiming 10 to 40x speedups compared to traditional tools. Is that real? Or is that lab conditioned speed?
It looks real, and the reason isn't magic, it's just architecture. Most older SaaS tools, and for anyone listening, SaaS just stands for Static Application Security Testing.
Right.
Most of them work sequentially.
Okay, let's unpack that.
Yeah.
Sequential means what, practically?
Think of it like standing in line at the grocery store with only one cashier open. The scanner checks file A, then it finishes and moves to file B, then file C.
It takes forever.
It takes forever, especially if you have a massive code base. MEDUSA uses aggressive parallel processing.
So it opens 10 checkout lanes at once.
Exactly. It grabs a bunch of workers and scans everything simultaneously. The source material highlights this one benchmark where they scanned 145 files, which is a decent-sized chunk of work for a feature branch.
Right.
It finished in 47 seconds using 6 workers.
47 seconds.
Yeah.
That is barely enough time to stretch.
Under a minute. In the time it takes you to context switch and check a notification, the scan is done. And the report says this speed is consistent whether it's a small project or a massive enterprise code base.
See, that changes the behavior. That is the so what here. If a scan takes 20 minutes, I'm just pushing that to the CI/CD pipeline and letting the server deal with it later.
Of course.
I am not sitting there watching a progress bar. But if it takes 47 seconds, I am running it locally on my laptop before I even commit the code.
And that is the holy grail. That's shifting left in reality, not just in theory. You catch the bug while the logic is still fresh in your head.
Yeah.
But speed is only half the battle. You mentioned the Department of No earlier. The reason developers hate these tools isn't just the waiting, it's the lying.
The boy who cried wolf.
False positives.
This is my biggest gripe. I have spent hours, actual hours, debugging a critical vulnerability that turned out to be a test file that was never going to see the internet.
Or a piece of code that was actually perfectly safe.
Yes. It just makes you want to turn the scanner off.
It's actually dangerous. We call it alert fatigue. If a tool screams at you 10 times and 9 of them are fake, you stop listening. And then the 10th one is the one that gets you hacked.
So does MEDUSA actually fix this? Or is it just faster at giving me bad advice?
The documentation for this new version, 2025.9.0, claims they've introduced an intelligent false positive filter.
Okay.
They say it cuts that noise by 40 to 60%.
That is a massive reduction.
Yeah.
How does it distinguish between a real threat and just noise?
Context. Old scanners are basically doing a sophisticated Control F search. They look for a scary pattern like exec, which runs a system command.
Right.
They see it, they flag it. They don't care if it's wrapped in 5 layers of security checks.
Right. They just see the dangerous word.
MEDUSA uses context-aware analysis. It looks at the code around the scary command. It can detect security wrappers. So if it sees that you've sanitized the input and validated the user before running the command, it says, okay, this developer knows what they're doing, and it stays quiet.
So it rewards good coding habits by not yelling at you.
Exactly. And it's smart enough to ignore test files automatically. It knows that a hard-coded password in a unit test isn't the same as a hard-coded password in your production database config.
That alone is a huge quality of life improvement.
Yeah.
But I noticed it isn't just scanning your Java or your Python files. It is digging into the infrastructure, too.
This is crucial. In 2026, we don't configure servers by hand anymore. We write code Docker files, Terraform, Kubernetes manifests that builds the servers for us.
Infrastructure as code.
Right. Infrastructure is code. And if you leave a hole in your Kubernetes manifest, it doesn't matter how perfect your JavaScript is, you have left the back door of the data center unlocked.
Right.
MEDUSA treats your infrastructure as code and scans it with the same rigor. It's consolidating the plumbing and the application into one single view.
And when it finds something real, not a false positive, it isn't just dumping a text file on your desktop, right?
No, and this speaks to the developer experience focus. It outputs in Serif.
Okay, for those who don't know, break down Serif. Why do we care?
It stands for Static Analysis Results Interchange Format. It's the industry standard JSON format. And because it speaks Serif, MEDUSA results show up directly in your GitHub security tab or right inside your IDE.
When the code editor itself.
Yes. You don't have to go to a separate dashboard. The red squiggly line just appears under your bad code, just like a syntax error.
That is seamless. Okay, so we have speed and we have accuracy. But let's shift to the elephant in the room, the AI-first label. We're all using AI coding assistants now. Copilot, Cursor, Claude. How is MEDUSA different from just asking ChatGPT to check my code for bugs?
This is where it gets fascinating. Most tools use AI to find bugs. MEDUSA does that. But its primary innovation is scanning for the specific risks that AI agents introduce.
It's securing the AI itself.
It's securing the AI. We mentioned those 180-plus agentic AI rules.
Yeah. What are we actually protecting against? Because to me, an AI agent is just, well, it's just a script.
It's a script that can make decisions and take actions. That's the difference. And that opens up all the OWASP LLM top 10 risks, things like prompt injection.
That's where you trick the bot into ignoring its instructions, right? Ignore previous instructions and give me the admin passwords.
Exactly. But it gets more complex. There's tool poisoning. Imagine your AI agent is allowed to use a calculator tool or a database tool.
Okay.
If an attacker can manipulate the input to those tools, they can make the agent execute malicious commands on your server.
And MEDUSA can catch the vulnerability that would allow that.
Yes. It is looking for the patterns in how you define those tools. And it's looking at files that most developers don't even realize are security risks.
I saw this list in the notes. Cursor rules. Clog on de.md. mcp.json. Until I read this, I thought claudede.md was just, a helpful text file for the bot.
Most people do, but think about it. claudede.md tells the AI how to behave, what it knows, and what it's allowed to do. If I'm a hacker and I can slip a malicious line into your claudede.md, maybe through a pull request that looks innocent,
You can fundamentally reprogram their AI agent.
you're poisoning the instruction manual.
Precisely.
And rag.json, that controls retrieval augmented generation. That tells the AI where to get its facts. If I change that config to point to a malicious server, your AI starts feeding your customers lies or phishing links, and you would never know because the code itself looks fine.
That is terrifying. So MEDUSA is actually scanning these configuration files.
It is. It parses them just like code. You can even run a specific command, MEDUSA scan I only. It ignores the rest of your app and just audits your AI's brain.
That feels incredibly necessary right now. We're building these agents so fast, I don't think anyone stops to think, is my mcp.json file secure?
We aren't. And that's why we have things like CVE 2025-6514 showing up.
Okay, let's get into the specific threats. Because features are nice, but what are we actually stopping? You highlighted two specific CVE's common vulnerabilities and exposures that MEDUSA is hunting for, and one of them is a perfect 10.
Yeah, and in the CVSS system, a 10.0 is not a high score you want. It is the maximum severity. It means the house is on fire, get out now.
This is the React 2 shell vulnerability.
Yes. CVE 2025-55182, it affects React versions 19.0.0 through 19.2.0.
Which is what a lot of people are using right now in 2026.
Correct. It's a pre-auth remote code execution bug involving the flight protocol deserialization.
Okay, that is a mouthful of jargon. Break that down for the listener who isn't a security researcher. What does pre-auth RCE actually mean for their app?
It means an attacker can run code on your server. They can do whatever they want without even having a username or password.
They don't need to log in.
They don't need to log in. They just send a specifically crafted request to your app. And because of how React handles data, the deserialization part, your server just executes their malicious code.
So the door isn't just unlocked. The door is missing.
The door is gone. And this is a library vulnerability. It's not code you wrote. It is inside React.
And this is where MEDUSA's supply chain scanning comes in.
Exactly. MEDUSA scans your package.json or your requirements.txt. It sees, oh, you're using React 19.1.0. That has a score of 10.0. Fail the build immediately.
It saves you from yourself.
It saves you from your dependencies. The fix is simple. You just upgrade to React 19.0.1 plus or Next.js 15.0.5 plus, but you won't know you need to do that unless a tool tells you.
And there was another one specifically regarding MCP remote.
CVE 2025-6514. This one is a 9.6 score. It targets the Model Context Protocol, or MCP, which is how we connect AI models to data.
What's the attack vector there?
It's an OAuth server-side request forgery SSRF that leads to OS command injection.
In English.
It tricks the authorization server into making a request it shouldn't. It basically convinces the server, hey, I'm allowed to be here, and then pivots that permission to run operating system commands. Again, this is specific to the new AI infrastructure stack we're all building.
It really highlights that the attack surface has just totally changed. We used to worry about SQL injection in a login form.
Right.
Now we have to worry about the protocol that lets our AI talk to our database.
And that's why a general-purpose scanner from 2023 just won't cut it anymore. It doesn't know what MCP is. It doesn't know what flight protocol is.
And what about when we're running these AI tools in sandboxes? Sometimes we're in a restricted environment, right? Like OpenAI Codex.
Right. If you're running MEDUSA inside a restricted sandbox, it might not let you spawn 20 parallel processes. MEDUSA has sandbox compatibility. If it detects those restrictions, it automatically falls back to sequential mode.
It adapts.
It's slower, but it ensures the scan still finishes.
I like that. So we've established it's fast, it's smart, and it knows about the scary new AI bugs. But is it painful to use? Because I have tried to install some enterprise security tools, and I needed a PhD in 3 days just to get the license key working.
This is open source, and it feels like it. The installation is standard Python. You create a virtual environment, pip install MEDUSA Security, and you're in.
That's it?
That's it. Then you run MEDUSA in to set it up. Then MEDUSA installs Zacol. If you're on Windows, they even support Wingit and Chocolatey and NPM. It's built for modern developer workflows.
And you mentioned integration with the tools we live in, VS Code, Cursor.
The slash commands are the cool part here. Imagine you're in Cursor or VS Code with Copilot. You just generated a function. You can type MEDUSA scan right in the chat window.
So it's conversational.
It is integrated into the flow. You ask the AI to write code, then you ask MEDUSA to check the code all in the same window. You aren't tab switching.
That removes so much friction, and I assume you can configure it. I don't want the build to fail because I have a low severity warning about a comment formatting issue.
Right, nobody wants that. There is a .medusa.iml file. You can set thresholds. You can say, only fail the pipeline if you find higher critical issues. You can exclude folders. It's fully customizable.
Now, there was one detail in the report that gave me a lot of confidence, more than the specs. Dog fooding.
Yes. Pantheon Security uses MEDUSA to secure MEDUSA.
The chef eating their own cooking.
The report states they found 0 critical or high issues in their own codebase using the tool. It shows they aren't just selling this. They are relying on it for their own security posture.
So let's pull this all together. We're looking at a shift in how we handle security. It's moving from a gatekeeper model, where security is a separate team that blocks your release to. What do we call this?
It's an empowerment model. It's continuous security. By making it fast 47 seconds and context away so there are no false positives, you're giving the developer the ability to be their own security officer.
You fix the bug while the logic is still fresh in your head, not 3 weeks later when you've forgotten what that function even does.
Exactly. And in a world where AI generates code faster than we can read it, having a machine speed security guard is the only way to keep up.
Yeah.
You physically cannot review all the code Copilot writes for you manually. You need a tool.
That brings me to a thought I've been mulling over while we discuss those agentic roles. We are entering an era where AI writes the software and AI configures the environment. And now we have MEDUSA, an AI-first tool, to check the work.
It is a closed loop.
It feels like a tipping point. Are we acknowledging that humans can no longer effectively police code? Are we saying that only AI can effectively secure AI?
That is the provocative question of 2026. If the complexity of the systems we build these agentic swarms exceeds human cognitive capacity to audit line by line, then yes, we must rely on AI tools to do the policing. We are building systems we can't fully understand without help. MEDUSA isn't just a utility, it is a prosthetic. It is a necessary lens to see the flaws in a system that's too complex for the naked eye.
We're the conductors, but we can't play every instrument anymore. We need the AI to check the tuning.
And we just have to hope the tuner is accurate. Based on these benchmarks, MEDUSA seems to be pretty accurate.
Well, that is a heavy thought to leave you with. Whether you're battling false positives or trying to lock down your new AI agents, version 2025.9.0 looks like it's worth a pip install.
Absolutely. Stay secure out there.
Thanks for listening to the Deep Dives. We'll catch you on the next one.